All right, let's see if we can explain the difference between a dot product and a cross product. I've got two vectors up here, and I've got them in red, vector A and vector B. Here's vector A right here, and here's vector B right here. They're at some angle between each other, and that angle is theta. So if I want to define A dot B, what I am saying is, we're going to talk about it mathematically and conceptually. What am I doing here? A dot B is the magnitude of vector A, which is this guy right here, times the magnitude of vector B, which is this guy right here, times the cosine of the angle between them, which is this guy right here. Now I can rewrite that as the angle, or the magnitude of vector A times cosine theta. All I've done is rewrite this order up here, times the magnitude of vector B. But A cosine theta, that's this green line right here. That is the part of A that is projected down onto B, parallel to vector B. So really, A dot B is the length of B times the length of A, which is going in the same direction as B. And therefore, if A and B are coincident, or if they're parallel to each other, A dot B is just A times B, because they are multiplications of each other. What part of A is going in the same direction as B? Well, the whole part of it. So the length of the way I can multiply these two vectors is just multiply the numbers. So I get A times B. On the other hand, if A and B are perpendicular to each other, then A dot B is 0, because there is no part of A that is going in the same direction as B. And so this is a way of multiplying two vectors together when I know the angle between them, and I'm interested in what is a scalar number that represents the length of one vector projected onto the other vector times that vector. So when I do A dot B, I'm going to get a scalar. I'm only going to get a number that represents the length of one vector times another vector times the cosine of the angle between them. Now when we look at the cross product, we are kind of doing something different here. The dot product was the vector length of A times the vector length of B times the cosine of the angle between them. But the cross product is the vector length of A times the vector length of B times the sine of the angle between them. And now when I look at this, I come over to my drawing and I see that, well, hey, if I look at the sine, that's now this blue, this kind of ugly blue line. That is perpendicular to both of these things. And what we're really saying is that this doesn't have any way, we don't have a way of relating to this in a two-dimensional layout. So we have to think three-dimensionally. So what we are saying is we are looking at what is the vector. This is going to be a vector, not a scalar. What is the vector that points towards the volume that A and B lay out for each other up into the third dimension? Now there's some mechanics for this. Let's say, for example, that we wanted to make a vector, this vector here, where we had 2i plus 3j plus 4k. And vector B was 5i plus 6j plus 7k. We're going to write it out vertically. And the reason we're going to write it out vertically, it's easier to see because we can use matrix mechanics to do this. So when I write this out, the cross product between these two vectors, A and B, I sort of ignore my top row, and then I do in blue here, what is 3 times 7 minus 4 times 6? So I write out 3 times 7 minus 4 times 6. And then For the second row, the j part of this, I'm going to sort of ignore this middle row, and I'm going to do the opposite order. Now I'm going to do 4 times 5 minus 2 times 7. So I write here 4 times 5 minus 2 times 7. Again, I'm just sort of taking the opposite tack to the first one. Then for the third component, the k part of this vector, I sort of ignore this bottom row and I go back to the way I did things. Well, that would be 2 times 6 minus 3 times 5. And so I write over here 2 times 6 minus 3 times 5. And then I just do some simple arithmetic. And of course you may, if these aren't integers, you're going to need a calculator, but this one is easy. So 3 times 7 is 21, minus 4 times 6 is 24, that's minus 3. 4 times 5 is 20, minus 14, that's positive 6. And 2 times 6 is 12, minus 15, that's minus 3. So the cross product of A cross B is a vector whose the vector notation would be minus 3i plus 6j minus 3k. So that tells us the cross product of these two vectors. Now, let's go solve the problem that we were working on yesterday. All right, now we look at the vector we were working on yesterday. We had two vectors, 8i minus 2j plus k, and vector B, 9i plus 2j plus 18k. Now when I write them vertically, I put 8 minus 2 plus 1 cross with 9 plus 2 plus 18. And again, I'm going to set up my big vector kind of I need a lot of room to work with here. So the first row, I seem to like cross out, not cross out, but I ignore this top row and I just look at the second and the third row. So I have minus 2 times 18 minus 1 times 2. So I write that up here. Minus 2 times 18 minus 2 times 1. And that's minus 38. Now the second row, I ignore this middle row and I do the opposite order. Now I have 1 times 9 minus 8 times 18. So I write 1 times 9 minus 8 times 18. That is minus 135. And I think this is what was different, what we did incorrectly yesterday. And then the third row, I ignore that third row and I just look at the top two rows and I go back to my same old order, which is 8 times 2 minus a minus 2 times 9. So I write 8 times 2 minus a minus 2 times 9, and I get positive 34. So my vector, that is the cross product between these two, is minus 38i minus 135j plus 34k. And I bet if you write that in there, you will get the right answer. And you can do the others exactly the same way.